Today's little spiel about probability, the book states, we are going to compute probabilities of events that are not independent. Or, the book says, you could also call them, if you're not independent, then you are dependent. What in the world does that mean? I didn't ask you to say that. What do you suppose that means? Are you dependent? Aren't you dependent? What's it mean to be independent? Logan?
By yourself.
Okay, by yourself. Dependent means you can stand alone, you don't need anything from anybody, blah, 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 blah. We are not looking at independent, we are looking at dependent, which means the probabilities are going to depend on what happens there. They can't stand alone. For example, let's write one down here. A bag contains 2 white marbles and 3 blue marbles. A bag has, what did they say? 2 white and 3 blue? Sure, I'll go back and look. Don't worry, it's not that far. 2 white and 3 blue marbles. 2 white and 3 blue marbles. 2 white, 3 blue marbles. What's the probability if 2 marbles are selected? If 2 marbles are picked, what's the prob? What's the prob of selecting 2 blue marbles, 2 blue marbles, A with replacement, and B without replacement. And we'll talk a little bit about that. If you see this problem in your book, your first step, Cabran, is to... No, you don't have to write all those words down. No. Thank you very much. In which case, you're going to draw, obviously, a very nice brown paper bag, about the size of a popcorn bag. And inside that thing, we have what? 2 white marbles. I would probably put 2 big W's. And 3 blue marbles. Blue, blue, blue. 5 total marbles, yes? And I am looking for this probability. I'm looking for the probability of picking a blue and a blue. But I'm looking to do it 2 different ways and 2 different times. One time means I pick a blue marble, then I put that blue marble back in and pick it again. The second time I pick a blue marble and I don't put it back in and pick again. And they're going to be 2 different probabilities. This first one, if I do replace it, it's going to look like this. Well, what's the probability of picking 1 blue marble out of that bunch? How many blue marbles are there? How many total marbles? 5. That's the first time. What's the probability if I take that blue marble out? If I take this marble out when I pick it, but replacement means I put it back in again, what is my probability the second time of picking a blue marble? Ryan Connor? Same thing. Now the probability of doing that back to back is what you get when you multiply those 2 probabilities together. The probability with replacement is 9/25. Those 2 probabilities together. Now, I have to do it again, and this time I don't replace it without replacement. So I got probability still of blue and blue. The first time isn't going to matter because it's the same as it was before. I get 3/5. But this time, ladies and gentlemen, and boys and girls, I take that blue marble out and I don't put it back in, that's gonna change my second probability. Because now I don't have 5 marbles in there anymore, nor do I have 3 blue ones in there anymore. Now I have only 2 blue marbles out of 4 total marbles. So my probability, and again I multiply them like I did before, up to you if you want to reduce before or after, this is the same as 1/2. 1/2 times 3/5 is 3/10. You have a 3/10 probability of picking those blue marbles right away. Which would be the same thing if I had those marbles on the bag and said stick your hand and pull out 2. That would be this. Okay. To do this, you'd have to say take that blue marble out, throw it back in, pull out another blue marble. Have we done this before?
Yes.
Wait, that's almost everybody except one. Take a look, please, at page 560, would you? We will look at practice A and B just because we can. Look at practice letter A. If a spinner is spun twice, are the events independent or not dependent? Independent or not dependent? And the question you ask yourself is your second spin in any way affected by what you get on the first spin? Claire says no. Okay, the only way that would happen would be if by some chance you could take things off and on the spinner, but it doesn't matter. It's like flipping a coin twice. It does not matter. You could flip, ladies and gentlemen, boys and girls of all ages, you could flip 5 heads in a row, and your probability of flipping that next one, what's the probability of getting a head here? 1/2. Okay? Even though you got all 5 heads, and you'd say, well, the odds are I'm not going to get them. No, it doesn't matter. This is still 1/2, because these do not affect that flip at all. Same thing with that spinner. You're going to spin that little spinner thing, and it doesn't matter how many times you spin it. If you cut it into 4 pieces, there's a 25% chance you're going to get one of those letters. So that one is definitely independent. Now look at letter B. 4 different cards, lettered A, B, C, and D are face down on a table with the order scrambled. As a card is turned over, it is left letter side up. Find the probabilities. So here you go. A, B, wait a second. I'll do this. All right. A, B, C, D. They're all scrambled up, so it doesn't really matter where they go. Come on, B. Can I get B? D. Dabka. Anyways, so letter A asks what question? They're scrambled up, turned upside down. You can't see them, so here, I'll make sure you can't see them. You can't see them. Letter A says, what is the probability of turning the A the first card? What is your probability of getting an A?
1/4.
Yeah, only 1 out of 4. 1/4 chance. Okay, your probability is 1/4 of getting an A. Letter B then asks you, what's the probability of turning an A and then turning a B? Well, the probability of getting the A is still 1/4, correct? But once you have the A turned over, let me find it. Which one was the A? This one? Once you have the A, that affects your next one because you don't have 4 choices anymore. You only have 3 choices, and how many of them are B's? Just one of them. So your probability is, now multiply them together, 1/12 that those are going to happen together. Correct? And then letter C says, what's the probability of turning an A, a B, and then a C? Well, A is still 1/4, because you have that pick, a B is still 1/3, but if you pick the B, if you've already picked the B, you know, your choices of picking a C is what? Yeah, there's two left turned over, and only one of them is the C. So your probability of doing those three in order are 1 out of 24 times. Guess what letter D is? What is the probability of picking A, B, C, and D in order? Think about it. Logan?
16.
So you're saying the probability is greater that you pick all 4 in order than if you pick just 3 in order? Probability of A, B, C, D. Maggie is saying, huh? It only goes by this thought here. If you've picked A, and you've picked B, and you've picked C, if you pick A, B, and C, what's the probability you're going to get that last card right? 9. 1/1. Because there's only one card left and it has to be the D. So it's going to be the same probability as this one. It's 1/4 to getting the first card right. Then only 1 out of 3 cards are left. Then 1 out of 2 cards are left, and then 1 out of 1 card is left. Probability. If you pick the first 3 right, you have to get the 4th one right because there's nothing left there.
Wait.
What just happened?
I don't know. Just
I think I pushed this thing. Don't worry, I can fix it. I don't want to, but I will. All right, that's enough of that problem.